All right, welcome to the second part in this video series. So I previously discussed what stress is, and now we're going to look at different states of stress or different stresses, and what's called the Cauchy stress tensor. So stress is a force divided by area, and so stress has a vector component and an orientation. So stress has a magnitude, a direction, and an orientation. So a force is a vector. It has a magnitude and direction. A scalar has only a magnitude. And a stress tensor is kind of like the next highest mathematical representation of, say, a vector. So a stress tensor, or in a state of stress, there are three orthogonal planes and three orthogonal vectors. So there will be 9 states of stress in a stress tensor. And in the stress tensor, each component or each of the stress tensor is typically defined by this sigma, and we call it, say, sigma xx. So these subscripts, this first subscript x, this represents the plane that the stress is acting on, and it's represented by the normal vector. So if you remember from calculus, you can define a plane by its normal vector. So this would be a plane defined by the normal vector in the x direction, which, if shown here, is a plane defined by 001, which is the yz plane. The next subscript uh, is the force vector. So this x would be a force vector in the 001 direction. So for this state of stress, it would say that there's a force acting in the 001 direction on the plane defined by the normal vector in the x direction. So this would be the stress defined by the the force vector in the x direction on the yz plane, and I've shown that here. This is your normal stress, and this is the x normal stress. Now, I'll do another example for this stress component here, this sigma xz. So this would be the stress as defined by the force in the z direction acting on the plane defined by the normal vector in the x direction, which would be the stress by the force in the z direction acting on the yz plane. And this would be a shear stress. And this stress would be the stress defined by the force in the y direction acting on the plane defined by the normal vector in the y direction. So it would be the stress in the y direction acting on the zx plane. And I think it's important to point out this notation. I've seen in other forms of literature that they seem to leave this out. I'm not sure if it's assumed that you're to know it, but this is the best way that I know to think of or interpret the stress tensor, and to think of these again. If you see this subscript, it's the stress acting on this first subscript, the x-plane, or the plane defined by the normal vector in the x direction, and the force in the x direction. And one last thing before in the video is that in the Cauchy stress tensor, it is symmetric. And that means basically this tau here is a shear stress. And what that means is the shear stress xy is equal to shear stress yx. And likewise for the other symmetric components. So if you look in the tensor here, uh, they're it's symmetric about the diagonal normal stresses. So that means for a state of stress, you can define it by 6 components of the stress tensor.